Okay, now let's take a look at this simultaneous equation. Now we're gonna solve this. There are essentially two key methods you need to know. It's either elimination or substitution. Let me just show you both ways. Okay, first method, elimination. Let's take a look. So in elimination, what you want to do is to make sure that there's a plus and there's a minus and the coefficient is the same for one of the letters. Let's say that I pick, I don't know, I see a plus and minus already for 5 and 2. So I'll just focus on the variable y. I'll make sure that these coefficients end up with positive something, negative something that are opposites of each other. The value is the same. So what's a common factor of 5 and 2? I think it's 10, right? How do you make 5 and 2 the same? 1 times 2, the other 1 times 5. So first I'll start off by labeling them equation 1 and 2. So how do I get a 10? How do I get a 10 from 5? I have to multiply it by 2, right? So we're going to take equation 1 multiplied by 2. Then this becomes 8x plus 5y bracket times 2 equals 9 times 2. What do we end up with? We end up with 16x plus 10y equals to 18. Let's call this equation 3. Next step. You have equation 2. Now that we have a plus 10y, I currently have a minus 2y. I need to make them the same value but opposite sign. One is plus, one is minus, so that's fine. 2, which is good, but 2 and 10, they are different, which is bad. So what do I need to do to make them the same? 2, I need to multiply by 5, right? So equation 2, I have to multiply by 5. I can't just multiply by 5 to that specific term on its own. I need to multiply the whole thing. So 6x minus 2y, 47 on the right side. I bracket this expression times 5 times 5. Calculate what you get. 5 times 6, 30x. 5 times negative 2, negative 10y. 47 times 5, 235. Okay, good. You can check that on your own. Pause the video to check. Okay, then you get our equation 4. Very good. Now that we have equation 3 and 4, but you will notice that there's a plus 10y and minus 10y. What do you want to do now? Add them. 3 plus 4. So it's just going to be copying and copying. This one plus the other guy, 30x minus 10y equals to 18 plus 235. Draw a line, a fancy line. You don't have to draw the line. Almost looks like you're doing primary school addition, right? But please don't do that. You have a calculator. Okay, 235 plus 18 is what you're doing on the right side. Just use a calculator. 235 plus 18. You end up with 253, right? But on the left side, you see plus 10y minus 10y. They can cancel away. 16x plus 36 plus 30x, you get 46x. Okay, good. So you end up with 46x equal to 253. Solving for x, you get 253 divided by 46. You get 11 over 2, which is 5.5. Okay, are we done? No, we still need to sub back in to solve for y. So we have 4 equations to choose from. 1, 2, 3, 4. Which one would you prefer? I would definitely not choose 3 and 4 because the numbers are big. I'll focus on 1 and 2 instead. 3 and 4 are actually derived from 1 and 2, so we should focus on these two. Pick your own poison. Which one would you like? They are both equally long-winded. I would choose maybe equation 1. So sub the answer for x into equation 1. You could also try equation 2. So we end up with 8 times 5.5 plus 5y equals to 9. So 5y equals to 9 minus away 8 times 5.5. Type in the calculator. 9 minus 8 times 5.5, negative 35 is 5y. So solving for y, you just divide by 5. Oops. Divide by 5 and you get negative 7. Answer. Next, we want to try the substitution method. So in the substitution method, what you want to do is to make x or y the subject and then substitute into the second equation. Okay, start with the first equation, make either the x or the y the subject, then substitute into the other equation. Let's see how we can do that. And you should notice it is very long. Let's say I start from 1, okay, and I try to make, for example, x the subject. Okay, so 8x plus 5y equals to 9. I can bring the 5y over, I get 9 minus 5y. Solving for x, I get 9 minus 5y over 8. Call this, okay, that's just x. Okay, then next I have to sub this x into 2. What do you get then? You end up with 6x minus 2y equals 47. But the x is replaced with 9 minus 5y over 8. Okay, good. So you see that it's getting quite complicated. There's fractions involved. Yuck. There's fractions and negative numbers. Very difficult. Very confusing, right? Prone to careless mistakes. So would you use substitution or elimination? Up to you. Okay, I'll show you both. Okay, so 6 and 8 cancel off. You're left with 3 and 4. So 3 here, 9 minus 5y there. You can multiply in 3 times 9, 27. 3 times negative 5y, negative 15y. All divided by 4. Good. Minus away, 2y equals 47. You have a fraction, you have a whole number essentially. What do you do with this sort of whole number looking expression? You rewrite it as a fraction, 2y over 1. Okay. Fraction minus fraction make what the same? Denominator the same. So we're going to multiply this by 4 at the top as well. Multiply by 4, and then we end up with 8y over 4. The denominator is 4, so I don't actually have to write it twice. I can just combine to one huge fraction. Then the 27 minus 5y, sorry, 15y, copy and paste, but you have to minus 8y. 2y times 4 is 8y. Minus 8y. Minus 8y. Equals 47. Okay, simplify the numerator. 27 remains minus 15 minus 8 becomes a minus 23y, all over 4 equals 47. Now divide by 4, you bring over, divide becomes a times. So you just left with the numerator equals 47 times 4. Let's calculate 47 times 4 on the calculator to simplify things. We end up with 188, which is 27 minus 23y. I'm running out of space here. So after that, let me just copy it at the top. Hope you're not confused. I'm bringing the working on top. So if you try to make y the subject, let's see what happens. Minus 23y, leave it alone, equals 188 minus away 27. Make y the subject now. I get 188 minus 27, all divided by negative 23. Then you can just type this whole thing in a calculator. Let me just bring it over to the other side. So you end up with fraction 188 minus 27 all over negative 23. What do you get? Oh, negative 7. Done. Same answer. Sorry, that's just 7. Sorry, that's just y, which is not x yet. We are still not done. We still need to solve for x. Now sub. Maybe I'll call this equation star. Okay, sub y equals negative 7 into equation star. What do we end up with? X equals 9 minus 5 times negative 7 all over 8. Calculate this. 9 plus 35 over 8. You don't need a calculate. You don't need mental sums for this, but I'll just do it for fun. You end up with 44 over 8. Cancel off a 2, you get 22 over 4. Cancel off a 2, you get 11 over 2. Which is 5.5, and it's exactly the same answer as before, 11 over 2, 5.5, negative 7. Okay, so write down the answer. 5.5, negative 7. Good. Not done yet. Still got part C and part D. Let's go. Write as a single fraction in its simplest form, fraction minus fraction. So whenever you have fraction minus fraction, you have to make what the same? Denominator the same. Maybe it's nicer, safer if you just put in the brackets around the expressions. So this one, you times x plus 4. Is that it? No, you also multiply the numerator. This other guy, you multiply with the other expression on the denominator, which is 2x minus 1. Do you stop there? No, you also need to multiply the numerator by the 2x minus 1. Good. Now that you have this, you can just write it down nicely. So x times x plus 4 minus away 3 times 2x minus 1, all divided by x plus 4 times 2x minus 1, which is it's an expression, which is itself. Okay, now we just multiply in, you get x squared plus 4x. This one, 3, I'll multiply in first. Maybe I'll do it at the side to save some space. This guy, if I multiply out, I get 3 times 2, 6x, and 3 times negative 1 is minus 3. right? Yay, very happy. 6x minus 3, I just write down 6x minus 3. I ignore everything else, just 6x minus 3, right? Wrong. What's wrong? This I copied out at the side is only this part over here, but there's still a minus in front. Please be very careful. So over here, plus 6x minus 3 should instead be the green color minus sign first, and then an invisible pair of brackets. Invisible pair of brackets. Please, please, please remember, after a minus sign, there is an invisible pair of brackets. Now, anyways, the denominator don't need to simplify further. Just leave it alone. Copy and paste the denominator. Then now you multiply the negative sign in. So you end up with x squared plus 4x minus xx. Minus bracket 6x minus 3. This becomes negative 6x plus 3. Right? Good. All divided by copy and paste the denominator. So far, okay, good. Moving on. So now you have a 4x minus xx, you get minus 2x, right? So x squared minus 2x plus 3, all divided by this guy. But just to be safe, let's just factorize this, and you should realize that you can get a minus 3 here and a plus 1 there, right? All over x plus 4 times 2x minus 1. Right? If it is factorizable, please factorize. If it isn't, then leave it. Here it is factorizable as x minus 3, x plus 1, then you should factorize it. And that will be your final answer. Good. Next, solve the equation. Okay, so now when you have a fraction on the left hand side and non-fraction, you can rewrite the non-fraction as just over 1. So fraction equals fraction. Rewriting it nicely looks something like this. Then you can cross multiply. So 11 times 1 equals to 3x minus 1 times x minus 3. Now 11 times 1 is just 11. 3x minus 1 times x minus 3. 3x times x, you get 3x squared. 3x times negative 3, negative 9x minus 1 times x. You get a negative x minus 1 times negative 3, positive 3. Okay? 1, 2, 3, 4. 1, 2, 3, 4. Maybe I label it 1, 2, 3, 4. Okay? 1, 2, 3, 4. Good. So now, if you try and simplify this, you end up with 3x squared minus 9 minus 1 is minus 10x plus 3 equals 11. I prefer my variables on the left side, so I'll just swap them around. This goes to the left, that goes to the right. Okay, and bring the 11 over. So you end up with 3x squared minus 10x plus 3 minus 11 minus 8 equals 0. Done. Not done, because we need to solve the equation. Oh, so now that you have a quadratic, just use a calculator. Key in the coefficients. 3 minus 10 minus 8. You end up with x equals to 4 or x equals negative 2 over 3. At this stage, if you want to show more working, you should actually write down this. Negative b plus minus square root of b squared minus 4 times a times c all over 2 times of a. You don't really need to simplify this expression, but if you want to, you can. I will leave it as an exercise. You will eventually end up with these two. Okay, so 4 negative 2 over 3 connected by an or, not and. Okay, moving on, we want to go to question 8. Let's take a look at question 8. Okay, here we have a cuboid with height x cm over here. So the width of the cuboid is 6 cm more than its height. If the height is, okay, let's interpret this. Width is 6 cm more than its height. So width versus height, which is longer? Width is longer. Height is shorter. Okay, so longer, would it be bigger than x or smaller than x? Height is x. If you're bigger, then you're bigger than x, correct? Width is longer than the height, means that you should be our expression that's bigger than x. So if it's bigger, would you plus or minus 6? Plus 6 or minus 6? Longer, so you have to plus. Ding ding. Okay? Can. So the expression for the width is actually, I assume that the width is represented by BF, x plus 6. Clear? Not minus 6. Let me confirm first. Width of the cuboid is 6 here more than its height. Yeah. Then the length of the cuboid is twice its width. Okay, I assume that length is referring to AB or EF or DC or HG. Right, it's twice its width. So if the width is x plus 6, what's the length? Twice, right? So 2 bracket x plus 6. Right? Good. So now that we have the dimensions, we can form an equation. So let's see. The length of the diagonal AG of the cuboid is 24 cm. This is when you really need to have 3D visualization skills. So AG is over here. Can you see that there's two key hidden right angled triangles? We draw another line. Can you see that even though this doesn't look like a right angled triangle, but this is a 3D drawing, so if you imagine you have a camera that's looking down from the top to the bottom, this shape here, even though it looks like a parallelogram, is actually a rectangle, right? A rectangular base from a top-down view. Imagine this is your eyeball staring down from the top. Yeah, it's actually a rectangle. It's just that from this point perspective, it looks as if it's a parallelogram, but it's not literally a parallelogram. Okay, here, even though it looks like it's an obtuse angle, but actually no, it's a 90 degrees. Okay, good. So we're going to translate this drawing here, which looks like an obtuse triangle, to a two-dimensional drawing, which is actually a right-angled triangle. So let's just draw that right-angled triangle first. Maybe a bit more slanted, something like this. There's a A, there's a B, and there's a F, right? 90 degrees here. I hope you are, the moment you hear 90 degrees, you should be thinking, oh, Pythagoras theorem. Maybe before that, we should make use of this information. The length of the diagonal AG is 24 cm. Sorry, no, that can't be used yet. Yeah, we need to work with this ABF first. So let's see. This sorry, no, I'm wrong. No, this is just, no, I was wrong. That's a simpler way if we start with the other right angled triangle. This AF is the blue color diagonal, right? That's one right angled triangle, but there's also another right angled triangle over here, GAF, right? Here to here. Even though it looks like a obtuse angle, but actually you must think 3D, so it's actually our 90 degrees here. So to make things easier, always draw the right angled triangle, something like this, and label GAF. Where's my X? Here. Where's my AG? There, pink color. Where's my AF? There, blue color. Any common lengths? Yes, the blue color AF. What do we know about AG? Length AG 24. Okay. Good. Sorry. So in that case, if this has two lengths already, can we figure out an expression for the AF? Yes, we can. So what rule can we use? Our theorem, Pythagoras, right? Sorry. Okay, so what's the equation we can form? Using a two-letter notation for the length, we can say AF square plus X square equals to 24 square, right? Good. So let's just make AF square the subject. So we get 24 square minus X square. Sorry. Notice that we are not making X the subject because over here, it's not useful. Okay, what's more useful is if we transfer this information and use it over in the second right angle triangle. Let's now look at the second right angle triangle ABF. Any lengths that we haven't labeled yet? Yes, x plus 6 here, and a 2 bracket x plus 6 there. Any other lengths? Yes, there's a AF, right? But what's AF? Oh, it's really just this guy, but you have to take a square root. So let's just write it down. It becomes AF equals square root of 24 squared minus x squared. I know 24 squared is a number, but I'm not going to write it down. I'll just leave it as 24 squared. And also I keep the positive root, reject negative. Okay, to make things simpler. Very good. So now I can label over here at the blue length 24 squared minus x squared. Good. With this diagram, I can now use Pythagoras theorem again. And I end up with 2x plus 6 square. This notation is wrong. You're missing a pair of brackets. Okay. This square, you must have an extra pair of brackets. Why? Because you're gonna distribute the 2 into each of the factor. 2 square times x plus 6 bracket square later. Okay. Just be careful of that. Then plus x plus 6 bracket square equals to the square root expression for AF. Whoops. And then bracket square. Right? Oh, but wait a minute. Square root and a square, they just cancel away. And they're just left with AF square, which was already written over here. So I could have been a bit more efficient by simply using AF square directly. Like this. Okay? Square the square root. They happen to cancel away. Okay, this is just AF square. Now we can form then now this is an equation that will eventually be simplified into this. Let me show you how. X squared plus 10x minus 66 equals 0. It will eventually become this format. Let's just expand this. So we get 2 square times x plus 6 bracket square plus x plus 6 bracket square equals to 24 square minus x square. Okay, at this stage I have no choice. I need to expand this already. 24 square, let's see what it is. Oops. 24 square 576. This guy, I'll be a bit clever here and simplify this 2 square x plus 6 bracket square as just 4 x plus 6 square. And then I realized that it's just 4 copies of apple plus 1 apple, where the apple is x plus 6 bracket square. So it's really just 5 copies of x plus 6 bracket square. Right? And I can expand the x plus 6 bracket square, so I get x squared plus 2 times x times 6, which is 12x, plus 6 squared, 36. Okay, I'm going a bit fast. Hope you're not lost with this part here. Multiply the 5 in, I get 5x squared plus, let's see, 60x plus 5 times 36, 180 equals to 576 minus x squared. But remember the end goal. We need 1x squared and equals 0 on the right, standard form. Equals 0 on the right means standard form. So over here, we don't have a 0 on the right. We have a 576 minus x squared. So what should we do? Bring over, exactly. So now we're going to do that. Copy the left hand side. Plus 576 becomes minus 576. Minus x squared becomes plus x squared equals 0. Clear? Good. Now we have 5x squared plus x squared. That gives you 6x squared. We have 60x, no other like terms, so just plus 60x. We have 180 minus 576. I need a calculator for this. You get a minus 396 equals to 0. Very good. But wait, are we done? No, we need this form, 1x squared. So what can we do? Divide by 6. So we get x squared plus 10x minus 396 divided by 6. What do you get? 66 equals to 0. And then we are done. Bracket shown. Okay, just to double confirm, form an equation in terms of x to represent this information and show that it simplifies to this expression, which I've copied over here. Yes, I have managed to show it. Next part, solve the equation giving our solution correct to 2 decimal places. I'm just going to use a calculator. Use GC, or if you really want to show the working, negative b plus minus square root of b squared minus 4 times a times c all over 2a. Okay, where a, b, and c are the coefficients of the equation. A equals 1, b equals 10, c equals negative 66. Type in a calculator and you'll get your answer. Let's see what it is. 110 minus 66. I get 4.5393 or negative 14.5393. Okay, then you want 2 decimal places. So sometimes the question will specify the degree of accuracy. If they don't, then you have to follow 3SF. Yeah, so let's just do that. So 4.54. This one will be, sorry, yes, correct. Negative 14.54, yes, as well. If you rounded off to 3SF, you would have ended up with negative 14.5, which is not correct. Not what they requested. They want 2 decimal places. So negative 14.54 and a 4.54. We are done. Part C, calculate the angle GAF. What's GAF? Let's see. GAF. This is a topic on trigonometry that you haven't learned yet, so we won't be covering it. Okay. But just for fun, let me just do it. So in this case, GAF, in this case, is an angle. You have opposite here and a hypotenuse there. We know x is what? X is this guy or that guy. But x is a length, so a length can only be positive. So that means in the context of the question, we would want 4.54 for the length of GF. So let me just copy the diagram over. Like this, and remove the x and replace it with a 4.54. Maybe it's better if I use 4.393, the more accurate answer. If not, there will be rounding error. So now we want to calculate angle GAF. So tangent theta equals to opposite 4.5393 divided by 24. Solving, you just take tangent inverse of that guy. So let's just calculate it. So tangent inverse, shift this guy, fraction 4.5393 divided by 24. You end up with I'm in degree mode, 10.710 degrees. Round off to, let's say, 3SF, 10.7 degrees. Okay, so 10.7 degrees. Answer. And we are done.